Good afternoon, everybody, and welcome to the ninth session of the summer term 2026 of Sunoikisis's Digital Classics. And this term is dedicated to exploring, as you know very well by now, digital scholarly editions in classics, Byzantine, and medieval studies. Today's session will be dealing actually with more material evidence. I mean, until now we've dealt a lot with text and textual analysis and literature. This time we're dealing more with material evidence, and the title of today's session is, as a matter of fact, Digital Objects in Research-Based Teaching. As always, if you're watching live, that is on the 23rd of June 2026, feel free to write in the live comment section of the YouTube video, and do tell us where you're watching from, and of course ask questions or leave comments that our speaker will address at the end of the session. Today's speakers are Elisabeth and Sven Günther. As always, we have a lot to cover and way too little time. So without further ado, I'd like to leave the floor to Elisabeth and Sven. Please, there you go.
Yeah, thank you very much for the kind invitation to speak here. So let's share our PowerPoint with you. And I will speak first. As I'm the dinosaur representing here the old methodology of our topic of today, which is about Roman coins, personifications, and the second part will be then on orange data mining and whether this program and the tools therein can be used to identify personifications. That will be the part of Elisabeth. And without further ado, as was said, we will start off. And actually, I want to start off with our material evidence, which are the coins. And you might have read beforehand a bit about personifications and the problematic terminology regarding this term and the concept behind it, because when we look at especially Roman coins, we find quite a lot of deities or divinities, gods, goddesses, or personifications on it, and the terminology varies quite often because there are different underlying concepts behind this. Terms and concepts. So when we talk about this, we have first of all to start not from the big concepts and the underlying conceptual reflections, but we have to start with the evidence. And the evidence is quite clear-cut. We have gods, goddesses, personifications on both the Republican and the imperial coinage, and we very often cannot tell whether it's a personification or a god or a goddess. This I want to exemplify with the first coin on this slide, which is actually from the Roman Republic from the year 62 BC. And as you can see, you have a female figure on the obverse, on the front side of the coin, which is veiled, so covered the head with a veil. And we would actually not know what kind of god, goddess personification it is, but it's actually written there, because besides a name, namely the name of the money of this coin, Paulus Lepidus, you can read, hopefully, on front of that face portrait, Concordia, concord, harmony. So with this, it's quite clear that this female portrait is meant to be Concordia. Now, Concordia, we could say this is a personification, namely to make a concept, an idea, harmony, concord, into a here female figure, quite often. These personifications are female figures, by the way. But we actually know that there was a temple of Concordia, a temple of harmony in Rome, and that this personification, goddess, however you call it, was worshipped. So with this, you already see that actually to say whether something is a personification or goddesses is based on our evidence, whether we actually know that there was a worship of this personification, which then would become a goddess in Rome, or whether our terminology is maybe problematic per se, because it's very much shaped by the Christian viewpoints that have been developed over centuries. Now, the more important point here is that Concordia appears on the obverse of the coin, and this is quite true for many of the goddesses or personifications we have on the Roman Republican coins. Very rarely these kind of figures appear on the reverse of the coin. Nevertheless, it's worth looking at the reverse of this coin, because coins, this is not just a small truth, have both a front and reverse side. And as you can see on the reverse, the back side of this coin, you see in the middle a trophy being placed there, which was a traditional symbol to show victory of the Romans. And you see Togatus, so Roman on the right-hand side, and on the left you see a bigger figure and two smaller figures which represent King Perseus and the two captured children of this king, who was the king of Macedon and was eventually defeated by Paulus, which is written in the exarch, so in the lower part below the standing line of trophy and the figures. So what does this victory that happened 106 years before the coin was minted have to do with Concordia on the obverse? That's actually a very important question we always ask ourselves when we look at Roman coins. How can we link it to actual developments, historical events, and so forth in the respective time? Here, it's quite clear the reverse is pointing to achievements of this Paulus Lepidus, who is mentioned on the obverse of the coin. So he traces back his family glory to this famous Paulus of 168 BC. And Concordia on the obverse is meant to show the new harmony that had been achieved in the year 62 BC following the conspiracy of Catiline, who, according to Cicero and others' view, tried to overcome the current res publica, the current republic, and to establish a tyrant state. Whether that is true or not, of course, depends on the respective narrative. Anyway, you see that Concordia is not just there because one wanted to allude to harmony, but because it served a specific purpose in that very specific historical situation. Now, if you look at the other three coins, which will be presented a bit shorter, you will see that actually something changes in the imperial period. And what changes is that on the obverse you see now usually the emperor or the empresses or members of the imperial family. So whether we go to the coin minted under Philip I for his wife Severina, or whether we look at Vespasian's coin in the lower register or right-hand side of it to the coin of Sabina, the wife of Hadrian, you all see on the obverse there is not the god, goddess, or personification, but what we look at is here the reverse, where these personifications goddesses are displayed. So you see, for the coin minted for the wife of Philip I, that Concordia is again presented here now on the reverse, and it's displayed in a totally different manner from the Republican times. The figure is not shown in portrait, she is not veiled, she is instead sitting on a throne or a stool, looking to the left, holding cornucopiae, these kind of horns of plenty in her hand, and patera in her right hand, which is a traditional symbol of divine sacrifice by libation. It's actually not just Concordia written there, but Concordia Aug with double G, which is probably alluding to the harmony of the emperors, as Philip's son was also meant with this, but it could of course also allude to the Augusta, so the empress that's displayed on the obverse, so that they both live in harmony, Philip I and his wife. What I wanted to show with this coin is actually that we do not have a continuity from Republican times to imperial times what regards the iconographic details of display. And this can be further shown by other coins, which are here represented in the lower register. So we have the coins of Vespasian, Vespasian being displayed on the obverse of the coin, and on the reverse we have Aequitas, so equity, that is shown there, again connected with the emperor, Equitas Augusti, the equity of the emperor. But how this figure is displayed reminds us moderns rather of justitia, justice, and actually we will also hear later on, justitia was rarely, or much rarer, displayed on Roman coins than Aequitas, and that's actually an interesting topic to talk and reflect about, because equity means a slightly different thing from justice, as you already see in the names. The fourth coin I want to show to you is the coin of Hadrian's wife Sabina, who is displayed in a very beautiful style on the obverse here, almost looking like the reverse figurine, which is Venus. Now, Venus is shown in quite different styles and with iconographic attributes, as we will see later onwards. But here you see that she is really shown in the beautiful style one can imagine now, with that clothing and holding also apple in her hand, which is of course alluding to the judgment of Paris. And when you look at the legend of this personification, you will see it's not just Venus in the dative here for Venus, but it's Venus Genetrix that is honored here. Genetrix meaning the one protecting the or building the gens, the clan, which is here the clan of Hadrian, which he traced back actually to the clan of Caesar and Augustus. And you all might know that Venus was the founding woman, so to say, of the gens Julia, where Julius Caesar derived from, as she is said to have had a son in common with Aeneas, whose name was Iulus or Ascanius, the founding father, so to say, of the gens Julia. Why Hadrian or Sabina puts it on a coin is quite clear. Hadrian needed this kind of legitimization in order to show that he is now in succession of Augustus and Caesar, the ruler that is confirmed and not contested as he was actually by many contemporaries. Now, when we have looked at this coin, you might have already seen that studying these personifications or goddesses, I exclude here the gods as most of the personifications are female, as I said beforehand, that this is a topic that is not easy to study for numismatists. First, not always you have an accompanying legend telling you what kind of personification or goddess it is. And second, you see that the style of showing these personifications quite varies. This is one issue. The second issue is, of course, that when we moderns use the terms personifications, goddesses, and so on, we have a modern understanding, as we talked about beforehand. But we, of course, should also consider whether the ancients and how the ancients thought of personifications. And actually, also in the preparatory material, we gave you at hand two important sources in this regard, and I will just shortly look at one source, the Rhetorica ad Herennium, a rhetorical treatise that was published in the 1st century BC, which talks about personification, but not with the term personificatio, which is a French invention in the early modern times. It talks about conformatio, if you look into Latin, which is translated here in English as personification. Conformatio est, personification consists. And then comes the definition by the anonymous orator. In representing an absent person as present, or in making a mute thing or one lacking form articulate, and attributing to it a definite form and a language or certain behavior appropriate to its character, as follows. And then come some examples, and I just want to quote the first one, which is about a city. You will soon see it's the city of Rome. But if this invincible city, the city of Rome, would now give utterance to her voice, would she not speak as follows? I, city of renown, who have been adored with numerous trophies, enriched with unconditional triumphs, and made opulent by famous victories, am now vexed, O citizens, by your dissensions. Her, the city, whom Carthage with her wicked guile, Numantia with her tested strength, and Corinth with her polished culture could not shake. Do you now suffer her to be trod upon and trampled underfoot by worthless weaklings? It's quite clear that the city now cannot normally speak, but by conformatio, being made into a form, she is now able to speak. And now I want to know from you, in which situation could you imagine a city to stand up and speak like this? You can write in the chat. Any idea in which situation do you think a city could be imagined to stand up and speak like it is quoted here? Maybe too hot to think about it. Is there anything in the chat, Martina?
No, not yet.
Okay. You might think of a specific performative situation. Yeah, it's theater. No? It's theater. So it's a situation when actually these kind of roles have to be filled with life. And this is now a very important point for our further research. We are dealing here not just with representations of these gods, goddesses, personifications in a form of religious devotion of the Romans, which there surely was. But it's of course meant to be a performative act to show the one or the other figure on the coins. So when we look at the coins, as we did, we always must imagine that these coins were meant to represent something in a kind of performance of the one distributing the coins. And this is an important point to consider when now Elisabeth takes over and shows you whether we can make this very complicated thing a bit simpler with the help of AI. So now,
Sven, may I interrupt you a second? We had a student
sure.
proposing asking whether this might have taken place in the Senate.
The coin distribution, or
I don't know what you were reading before.
This might have been, yeah. So of course also political theater is a place where this is represented, and it reminds us very much, of course, of the writings of Cicero, speaking up, and also very often inventing figures who speak the one or the other thing. The second example I left out here for the reasons of time is actually about the elder Brutus, so the one who was murdering his own sons when they tried to bring back the kings of Rome in the early days of the Republic. So it's actually something that we have confirmed by other writings, that such kind of theater, political theater, was performed also in the Senate or other occasions of or political speech. That's correct.
Thank you very
okay,
much.
Then let's switch to Elisabeth.
Yeah, thank you very much, Sven. So hello, everyone, also from my side. I will contribute the second part, the AI part, so to say, on the basis of what Sven has already introduced to you. You have learned that on the reverses, on imperial coins, we see a lot of different personifications / gods or goddesses. You have seen that it is quite complex from a semantic viewpoint, that it is also not so easy to access them from an iconographic viewpoint. On the other side, we find them in large numbers in the imperial time, really stretching from the beginning of the imperial period until late antiquity. These personifications and also the goddesses and gods, they have special attributes they carry. So to some extent, this iconography is fixed, although not fully fixed. So from this side, if you see it, personifications are the perfect test for pattern recognition. And the question is, how can we apply AI and pattern recognition to study these coins? Can we identify personifications on coins? How maybe can we improve what we are doing, improve the method? And starting from this, how can we really bring together different methods to study these images and learn more about the social background, the political background of these coins? the context, so to say. I will quickly start to give a very short overview over the topic pattern recognition. Of course, pattern recognition, there's a lot to say. I will keep it short and I will focus mainly also on the question we have today. So don't be disappointed if I don't talk about everything. I'm also not an IT person myself. I'm just an archaeologist. But I will try my best to introduce this topic to you. And of course, you can ask questions at any time. I will also ask questions to you and you can answer then later in the chat. So stay alert. Okay, so first of all, how does pattern recognition work? So for pattern recognition, we use CNNs, and CNNs are convolutional neural networks. They are, just as the name says, are modeled after the neural networks in our human brain. So the basic interest in artificial intelligence was indeed to model human intelligence, and intelligence is in the brain. So the idea was to model the human brain by an algorithm. So the similarity between a mathematical function and a neuron in the human brain is that they need an activation. This activation, as you know from school, is needed in the neuron, the human neuron, to pass on information. And we have the same thing in the artificial neuron. And there is one mathematical function, the rectified linear unit, and this is an activation function in deep learning, and this introduces nonlinearity into the function. So if you have just a linear function, it's a very simple function, but to do pattern recognition, you need something more complex, and this is why you use the rectified linear unit. So as you see, what is in our brain, a physical neuron becomes a mathematical function in this artificial neural network, and this artificial brain works like a big network of these mathematical functions, and they are, to some extent, they are connected, and to some extent, they are not connected. These CNNs detect patterns in images, especially edges and lines, by breaking down the information into numbers. They apply filters. These are matrices, so you see this also here in the image. And these matrices identify the patterns. The filter matrix is always a bit smaller than the image, and this produces feature maps which then become smaller and smaller. So on the very left, this big rectangular thing or net is the input layer, and you see the input layer is the image. It is made of pixels, and the gray part is then the matrix, and the matrix goes, so to say, through the image, looking for these special patterns, and then it produces the feature maps, and the feature maps become smaller and smaller and smaller and smaller until we come into the output layer. And while the feature maps are here two-dimensional, then the output layer has only one layer left. This becoming smaller and smaller is called pooling. In addition, the neural networks are organized in layers which are folded, and convolution means nothing else than being folded to interconnect them. But as I have said, not each and every neuron is connected with each other, and only the information regarding patterns that is relevant passes through the network. So according to the the architecture, so to say, of this large network of mathematical functions, this architecture influences then, of course, the result. So which patterns are detected and which patterns are relevant then in the end for the output. Only the last layers, the output layers, you see them here on the very right, are fully connected. And they serve to sort the images into categories. And these categories we call classes. So this is exactly what the CNN is made for. It is to classify the images. For example, you give a bunch of images, and it should then say whether you see a cat on an image or a dog, for example. So you see that also these classes must be defined beforehand to train the CNN. And in this training process, there is a feedback, so whether the output is correct. So the decision of the algorithm to say this image belongs to the class of a cat or the class of a dog. This is what is made for, and if this is sorted not correctly, then there is a kind of feedback to improve this algorithm. And the correct classification is called the ground truth. So the ground truth is this image shows indeed a cat. And if this is wrong, then there will be an alteration via feedback loops. And then the algorithm adapts the filters that are placed onto the image, so to say. And then it can improve the output. So in the end, the output is, of course, statistically. So you don't do this with 1 or 2 or 3 images, but you need hundreds of thousands of images in the best case to train this algorithm. And this learning process is then called deep learning. So as I have said, for sufficient training, the CNN needs a very high number of images. And if you have a too small data set, this will cause some errors. So this will cause, so to say, what we call a bias. So this is the preponderance of features that are irrelevant for the CNN's task. So, for example, if you train the algorithm to identify either cats or dogs, and all the cat photos you give into the machine are color photos, and all the dog photos are black and white photos, then the algorithm will very probably take the most simple feature of the image. This is either color information or not color information, but it will not really learn the patterns. So it is very important to have the right data set for the training, a large data set, but also a data set that in best cases does not contain any biases. And then, of course, another important question is how to train it, to train the algorithm either with, so to say, human help or without. So if it is without any help, we call this unsupervised learning. And then the algorithm just learns, as I have said, by the feedback whether the ground truth was fulfilled or was hit in the output layer or not. But there's also another way of training, and this is the supervised learning. In this case, humans can help the algorithm to train. For example, you can annotate some parts in the images to show the algorithm that these parts are the most important features. For example, if you have cat photos and dog photos, you might actively tell or annotate this kind of image animals in the imagery. And then, of course, the result will be better. But both versions work. So having told you this, I would like to go more a bit into the program I will introduce to you today. So this is the program Orange Data Mining. So this is a program developed by originally for statistical analysis, but it has special widgets, and these allow us also to do pattern recognition. And CNNs are inserted in Orange data mining with the widget image embedding. So I have shown this to you. I will also show you a bit later that in Orange you use widgets and you connect them with each other, and then you get something they call a data pipeline. In this case, you use import images, so you can upload from your computer a file with a certain number of images, and this data will then flow into the image embedding. And here is the AI of Orange. The AI is, as I have said, in the embedders, and the image embedding reads the images and it uploads them either to a remote server, or it can also evaluate them locally. They use deep learning models to calculate a feature vector for each image, and then this feature table, so it's a big number, a lot of numbers, a row of numbers. This will then be used by the statistical widgets to further evaluate them, and then to sort them into the classes. So the sorting into the categories is not done by the AI here, but by a statistical tool. Image embedding offers you several different embedders, and each one is trained for a very specific task. You see all these embedders available in the list here. So this is just a list I took from the website, and if you go to this link, you can also find more information about them. So we will today have a closer look at the SqueezeNet. SqueezeNet is a small and fast model you can use locally, so you don't need an internet connection. And this SqueezeNet is a deep model for image recognition that is based on AlexNet. So this is a kind of common and well-working CNN, but it is of much smaller size. So it's kind of condensed version of the CNN, and this makes the performance fast and very effective. As you see, we don't have here a real data set. The training data is not only the images we upload, but the training data is a data set called ImageNet, which means that the embedders have been trained beforehand. So we call this pre-trained. We have a pre-trained CNN. We use then, or we refine this with our images, and then we have the statistical tools to sort these images into classes or categories. Furthermore, SqueezeNet and all the other embedders you see here learns unsupervised. This means, just as I have said before, that no human agent tells which patterns are relevant by a manual annotation, but the embedder, so to say, figures out itself what is a relevant feature in the image to sort it into the right category. This means that to some extent, these embedders are not transparent for us. They are kind of black box we cannot really look into, and we can not ask this algorithm why he sorts an image into this or that category. We can just try from the result we have when we change the images, our image set, we can just try to get an idea which features have been taken as relevant. And this is exactly what we will do today. So while SqueezeNet is pre-trained on this ImageNet dataset, it can be adapted to our dataset. And for this task, we need a certain number of photos of Roman coins. And some of these coins are then used also as a training data for the CNN to learn the specific features of the Roman coins. And yeah, this is exactly what we will do then later. So the other embedder, so today we will work with SqueezeNet and also with VGG19. So this is also a very common CNN with 19 layers. So you see it's a bit bigger than the VGG16. And this also has been trained on the ImageNet dataset beforehand. So having talked about this, I have a first question to you. And this question is, what do you think are the limits of this orange data mining when we use it to identify classifications on Roman, identify personifications on Roman coins? So what I mean with to identify Roman coins is that we ask the this data pipeline, so the connection of the embedder and the statistical tools, to sort our images of our photos of Roman coins into certain classes. So, for example, to sort them into the class of with the name of a certain personification, for example, to sort them into the class of Concordia, or what you see here is Equitas, equality. And we also have then later Venus, the goddess of love, so that we show different coins to this algorithm, and then the algorithm sorts it into, so to say, into the classes of the respective reverse personifications. Okay, so what do you think are the limits of this program Orange when we use it on Roman coins? So you can just write into the chat. I can now also see the chat, but Martina can, of course, also read it out. Does anyone have an idea?
Yeah. Let's wait for some ideas. There's definitely some.
So maybe just to give you a small hint, I mean, there are a lot of answers possible or questions possible. If you think about the training of this algorithm, do you think that it is very suitable to be used for Roman coins, or do you think maybe it's a bit challenging?
We have a question in a comment.
Maybe it would not be able to distinguish between personifications and empresses. Okay, so I'm not so sure about what is the thought behind the question. So do you mean with empress that sometimes also empresses are represented on the reverse of the coins? So if it's that, certainly yes, because these small figures of empresses do usually not really have a portrait head. And this is why in many cases it is a kind of openness in the image, whether this is actually personification or goddess, or maybe the empress shown on it. So I think the thought behind is also that for more complex questions related to the historical context, of course, Orange would not be able to give us an answer, because it can only detect the patterns. So first of all, we have to try to train the algorithm to detect the patterns, so to say, correctly. Yeah, you see here Equitas. She always holds the scale as an attribute, and she holds the cornucopia, so this horn of plenty. But you also see that sometimes she holds a scepter in her hand. So the patterns in the respective coins, they can quite vary. And this means that we will need probably a very high number of coins to teach all these variations to the algorithm. And this can be indeed a problem, yeah, to get enough coins to let the algorithm learn these patterns. So some other ideas. I think there's so many things to see limits here, I admit.
May also the moderator ask a question?
Yes, of course. Very welcome.
Would it, I mean, does the color and or the material and or the patina have an influence?
Thank you very much. So this can be also a problem. As I have said before, we must be very cautious not to get a bias into our data set. So we can imagine that maybe we have a preponderance of certain iconographies on certain denominations, for example, on gold coins or silver coins. And if we don't take care of that, it might cause a problem. Then it would maybe be better to use black and white photographs, yeah, to identify the personifications. But we will see later that this is not a big problem. It actually works quite well. But another question, the patina, yes, it is a problem. And maybe you have all also thought about it. These coins are not preserved perfectly. You also see this in the example. No? They have, they are all not perfectly round. They have maybe some damage. In some cases, people have touched them, so you don't see the details very well. And this is a very big issue if you do pattern recognition with archaeological objects, that they are not preserved perfectly. So you also have to keep in mind the state of preservation and also quite big variation in the shape of the objects. And this, and we will see this also later, can cause indeed biases in the end. But this is not the problem of Orange. This is a problem, a general problem of pattern recognition, if you apply it on archaeological objects or Roman coins.
Thank you very much.
Thank you. Yeah, I would say one problem. So I just continue talking, and if someone writes something, you can read it out to me. So what I see as one of the main problems is indeed the pre-training. Yeah, as I have said, Orange data mining is pre-trained on a data set called ImageNet. Maybe some of you know it. It's a big data set of everyday photos. Yeah. what could be the problem if you use training data that only contains everyday live photos, and then apply it to Roman coins? Maybe someone has an idea.
Do you see this, Elisabeth?
I see this, yeah. If the model is trained on realistic images, ... So I thought maybe
Yeah,
there's a
yeah.
second part
Maybe
of the
something else is coming.
sentence.
Yes, perhaps yes. If the model is trained on realistic images and we are then trying to recognize patterns of like highly stylized and idealistic things, I think that might be. Wait. There's something coming.
How would it be able to recognize mere drawings? Yes, exactly. No? So it very much depends on, so to say, the style of the photos they learn, and of course also the objects. So I mean, here Aequitas, she holds a scale, but this is not the normal shape of the scale for us. Yeah, this is a Roman scale. Or she holds a cornucopia, this horn of plenty. You never see this usually in daily life. So there are a lot of details in this photo you cannot really learn from the pre-trained data set. And then the different style. And in archaeology, we know that if you train algorithms to recognize very well, I don't know, vase paintings, it is not so good to recognize then some reliefs or so. No? So it really also is then kind of focused on a special medium. So this is one of the big problem. And the other problem is that Orange is, as I have said, unsupervised. So it just learns by itself. You cannot tell Orange, look, this pattern is a scale, or this pattern is a horn of plenty. But these are the attributes that lead us as humans to the identification. But Orange cannot learn it. So it will just see a lot of lines in the coin, and then come from this to this vector numbers. And from this, then you go to the classification. So it is a totally different way of how numismatists would do it. And as another issue is, you see here the legends. The legends are words, but Orange cannot read these words. It is part of the image. So every stroke in the legend, even if it's just the title of the emperor or the name of the emperor, will be also seen as a pattern in the image. And this can also cause some biases. So you see that there are indeed some quite narrow limits of Orange when we use it to identify personifications on Roman coins. But nonetheless, I will show you that it works. Okay, I go back to my slides, and in the background, I would like to open the program for you. But I think we can also do very well with the slides. So what you see here is our first experiment, so to say. And what we will do now is to sort the images of the coins into what we call a confusion matrix. So the confusion matrix is a table. So this is how it will look later, is a table that shows us how well, in the end, our algorithm, our Orange data mining works. Go back here. So on the left side, you see now the data pipeline we need to create such a confusion matrix in Orange data mining. You have, again, import images. You already know this widget. This is the upload of the photos of Roman coins we have on our computer. You can also add an image viewer and look at the images in the program. So it makes things a bit easier. You have then the image embedding, and you can choose one of these pre-trained embedders, or it's a small part of a CNN you can use. And then via the widget test and score, you can then create a confusion matrix. Test and score is very handy because it gives you an idea of how well your data pipeline works. I will explain it in a minute. And this here on the very left is logistic regression. So this is the statistical tool that helps to classify these vectors that the image embedder has produced for us. The algorithm sorts our photos based on its pre-training into the categories we tell it. So we say we have 3 categories. This is Aequitas, Concordia, and Venus. So 2 personifications and 1 goddess. And then Orange Data Mining will sort all images into one of this category. So no matter whether this, works or to say, one photo is then sorted into the best fitting category. So there's no way Orange Data Mining can tell us, for example, it does not fit in any of these. So it will have to sort it into one of these 3 categories. And test and score can find out how well this works. So Orange Data Mining can then check whether this classification is correct. Because in import images, we can already teach the program whether or in which category the photo fits. This is very simple because import images uploads the photos from files. And we can say this is the file with photos of Aequitas. This is the file with photos of Concordia. This is the file with photos of Venus. And after the classification of the photos, it can then check whether the embedder and the logistic regression have done the right thing or not, which photos have been classified correctly and which have been misclassified. And you see this then in the table we call confusion matrix. So these are photos that are actually Aequitas and are predicted to be Aequitas. So 5 photos of 68 in total have been sorted correctly in this first experiment. Then 12 photos of Concordia have been predicted to Concordia, and 13 of Venus have been said to be Venus. But there are also some misclassification. For example, this is Aequitas, actual Aequitas, but it has been predicted to be Concordia. So with this table, you get a very good impression how well your data pipeline works. And you can, via test and score, also get a proxy of how well it has worked. And this is called the AUC. This is the area under the ROC curve. So this is a statistical method to get an idea how well a model works. So it is, more correctly, the plot of the true positive rate against the false positive rate. So I think it's enough to know about it. It is just a statistical method to say whether our predictions are good. And if the AUC is 0.5, then it's absolutely random. If the AUC is 1, then it's perfect. So you see in our first try here, we used the embedder VGG19 and the AUC is 0.673. So it is not random, but it's also not very perfect. So it would be better to have something over 90, 0.9. And you see, if you use another embedder, this is the SqueezeNet, the one that works without internet, is very small, very handy. It indeed works better than this very large one. So the AUC is 0.74 in this case. So I have another question for you. Looking at these results of our first experiment, what do you think? To what extent can the confusion matrix and this AUC really tell us how well the pattern recognition works? And what do you think are the limits of these methods? So especially maybe if you compare these two confusion matrices. So if you have a look which are classified correctly, these are here the violet ones. These are the correct ones. And the other ones are the misclassified images. And you quite see some differences if you compare the two confusion matrices.
Sorry, I keep switching between the two comments. So this was the first one, and then it goes on like this.
Okay, so the idea here is that the statistics are quite clear, but the black box problem remains, and this is absolutely correct. So we can see, okay, this image has been classified correctly to be Aequitas. This has been identified correctly to be Concordia, but why? We don't know. We have no idea. We can now, and we will do this now, try to get a closer idea why orange data mining has this or that result, but there is no function in this data mining that gives us an idea. And this is also a big problem in pattern recognition in general, that it is very difficult to get an idea why the algorithm has classified something or misclassified something. Yes, exactly. Another problem of these two matrices, I think, is what does it mean the pattern recognition works well? Does it mean that it is able to correct a very high number of images correctly? Or does it mean that some specific images have been put into the right category? If we see that here we have maybe, I mean, it's a better AUC, but in the case of Venus, for example, yeah, in the case here of Venus and Concordia, we see that more images of Venus have been said to be Concordia than in the, so to say, verse model. So especially if we deal with low number of examples, I think that the confusion matrix is not always the best method to tell us whether a model works well or not. And it very much depends on our research interest. Yeah, what do we really want to get out of this data? I think also for this, the confusion matrix and especially also this AUC does not always work. It gives us a number, something we can operate with, but the information in the end is quite small. Yeah. And now I have two, another question for you. Talking about this classification, correct classification and misclassification. You see here all the images of Venus that have been classified correctly. I have to check whether these are, whether this is, whether this is done with the VGG or the SqueezeNet. I'm not so sure at the moment. Concord said to be Venus R5. I think it's a SqueezeNet. So these are the Venuses set with help of the SqueezeNet embedder to be indeed Venus. This here are coins that show equitas, but are thought to be Venus, predicted to be Venus by this SqueezeNet data pipeline. And these 4, they all show Concord, but they are also predicted to be Venus. So if you look at these images, do you get an idea which patterns might have been relevant for the classification of Venus? So you can look again. So these are the Venuses, and these are the misclassified ones. Maybe I go back and forth. I don't, if I tried to put them on one slide, but then they were so small, it was not really handy. So these are the real Venuses, Venuses. And these are coins that were predicted to be Venus, but are not Venus actually. Does anyone have an idea? Martina, you can, of course, also.
No, I'm also making it bigger so that. So
I think you put the slides also in the
exactly
among the links, right? So everyone can also open
precisely. And now I will put it again in the chat,
yes,
so that people can have a look. But off the top of my head, I don't know, I would say like standing female figure and like with doing something with their arm.
Yes, exactly. So
and we have a student who is a bit desperate. So am I. I'm like just throwing ideas off the top of my head. What I can do is like to say it's perhaps a woman, but that's yeah.
But that's not the problem. So you can just look. So which features are in these images that seem to be relevant to say it's Venus? So I think it's especially in the ones that are misclassified. It thinks, well, it does not think because it's a machine, but it predicts them to be Venus. So there must be a pattern in them that is connected with the classification of Venus. I mean, for us as humans, it's clear, or maybe not clear, or maybe we can read in the legend, we can read Venus or read Concordia, then it's maybe more clear. But the algorithm can only look at edges, strokes, circles, maybe.
I think that the only thing that actually changes are the attributes, right?
Yes.
More or less, like if
and the posture, so Concordia
and the posture exactly
seated, and there's also one seated Concordia.
No, that one is really, so the seated Concordia, I really struggle to follow the thought behind.
Yes. I have to say, me too. Because, and this is part of this black box phenomenon, is that in the end, we can never prove it. Yeah, we can just say this is more likely or less likely. And for researcher, it's a problem, no? Because we need to make things transparent. But in this case, we cannot really do it. Okay, I can propose you my thoughts, and then you can think about them and judge whether you think I'm right or I'm mistaken. So one idea, I mean, I also know the whole data set, so maybe it's a bit more easy for me. So one thing is, I think, that many of these Venuses or Venus coins are gold coins. And some of the misclassified ones are also gold coins. So there might be a bias. But it's not only the gold. So it's not the only thing the algorithm looks at. It also works. I mean, I also tried this with black and white photos, and it's in the seen from the AUC, it's not a big difference between the color photos and the black and white photos. If we look at the Venus, in many cases, Venus holds her right hand, her left hand up, and it is, you see here, like sorry, no, like a no, I missed the English word. It's not stretched out, yeah, but it holds it in a 90-degree angle to some extent, or holds it a bit higher in many cases. And this is also what we find here in the misclassified ones, but not in all of them. In the ones correctly classified of Venus, we find in many cases here a legend saying Venus, just Venus, Venus. So this might be here also here a pattern that allows a right classification. Nonetheless, we don't really find it in the misclassified ones. What is a problem for the data pipeline, and this became clear when I was working with it, are the legends. So the more complex the legends are, the more difficult, so to say, is it to get it into the right category. So there are more misclassifications if there are more letters on it. And this is, I think, quite clear because it is also a pattern. And the more pattern is in the image, the more difficult it becomes to be classified. Okay, so you can think about whether you find this convincing or not. What I wanted to show to you is that there is indeed a big black box here we have to struggle with, and we can only try to modulate maybe the data set and then see the classifications and get an idea through this which features are relevant or not, but we are not able really to prove it. Okay. Let's have a look at the last experiment. We want to build a machine that can identify personifications.
Elisabeth, may I interrupt you a second? We have another comment. I'm so sorry.
Yes, exactly. Yes. This is exactly what I say. So it cannot read a V or it cannot read an E, but it can recognize the pattern of the V. And if it's always in the same spot of the coin in relation to other patterns, then this can be a feature relevant. You also saw that in the case of Concordia, this O letter is quite close to the offering bowl. So this also, I can imagine, is a very typical feature and allows also then the algorithm to sort it into the right category. And not only the algorithm, but also the statistical tool to be more correct. Yeah. So you also see it's a problem that they have not always the same attribute, but there is variation in them. They don't always have the same legend. There is variation, and this variation is a problem for the pattern recognition. Okay, let's move on to the machine to identify personification. And the idea is that for those people who have, or for whom it is maybe a bit difficult to say this is Venus on the coin. We might build a machine, put the image in, and then the machine says, this is Venus. Or the machine says, this is Concordia, or this is Aequitas. We can do this with orange data mining. And you can already think about whether you think that this machine works well or not. Okay, how is the data pipeline? You know most of this data pipeline already, although it looks a bit complicated. You know exactly this part here. This is the confusion matrix part we produced. And this the results of this embedder here is then connected with a second pipeline via the widget prediction. So this is what the prediction is exactly what we want to do here. We have a second smaller pipeline, and in this we add an absolutely unknown photo. So it is a photo of a Roman coin, and it is unknown. Then we also have to do an image embedding. Of course, we use the very same image embedder than we use for the confusion matrix. And then the number vectors of the image embedding go into predictions, and prediction then predicts the category, but based on the image embedding of our data set. So it knows the patterns of our Concordia and Aequitas and Venus coins, and based on this, it then predicts the classification of one unknown photo. And prediction can say us how well this works. And the question is this a nice and possible feature for coin attribution, especially if you don't know well the iconography? So this is what happened. So I uploaded 3 coins that are all in the coin collection of the institute where my husband works. So this is a coin showing Venus lifting her veil. This is a coin of Concord seated with double cornucopia, and both you have already seen in Sven's part. And a third one, this is Aequitas. You can see here the scales, and she holds a scepter. So what does now our prediction tool say? The prediction tool says that this coin here is Venus. That's correct. It says this coin here is Concord. Also correct. And it says this third coin is Aequitas. It's also correct. So it has indeed sorted all of these coins absolutely correct. However, if you look a bit more into the numbers, you see that it is not that perfect. You see that with regard to Concordia, prediction says it is Concord by 99%, but there's 1% that this coin shows a Venus. It is even a bit more in case of Aequitas. So our prediction widget says this coin is Aequitas with a prediction of 70%, a possibility of 70%, but with 28% possibility it is Concordia, and with 2% possibility it is Venus. So it is indeed not that perfect, because there is a nearly 30% possibility that it shows Concord. Now, in a second experiment, I changed one of these coins, because this is the coin in the Institute's collection, but it's very worn out. So you see, very difficult to detect any pattern in it. Yeah. And if we use this instead of this very nice one from the RIC website, you see that the prediction is not good at all, but now it is thought to be Concordia instead of Aequitas. And with this, we also see that the state of preservation is, as we have said in the beginning, really an issue. And in many cases, we can not really change this. Yeah, we have to work with the data we have. But yeah, in many cases, the coins are worn out and not in a perfect condition as we find them usually on the different databases, image databases, and so on. So my question to you is, what do you think? Is this would this be maybe a useful tool for you to identify personifications and goddesses on Roman coins? Or do you think it is not so useful? Do you think it is reliable enough? Or would you say, I don't really trust these results?
Well, I'll chip in, and I mean, I think it's actually quite. It yields quite good results, but again, I've never experimented with this. But of course, I have to always think of Byzantine lead seals, and I mean, we do not have personifications. I mean, apart from Victoria, very very early on, but that's not. It's not that interesting, but we do have a lot of different, but in some aspects quite similar iconographies of saints, and that's, I think, a comparable example, because sometimes the pose is slightly different, the attributes are slightly different, and of course for a trained eye, human eye, a person who has seen hundreds of thousands of seals in their life, of course you can say, okay, St. George, St. John, whatever. But of course it also takes time to train both the eye and the model, I would. But we do have a comment.
Okay, it's useful, but without the names, I would be completely lost. And in counter distinction to myself, it gives me the figures, numbers of insecurity. Yeah. So I also think at the first sight, it looks quite nice. So if you have maybe an app, I mean, there are already some apps like this doing coin attributions. And at first sight, you think, oh, nice, it works. But if you look a bit closer into the numbers, you see it's not that perfect. Yeah, it's maybe just this or that probability to be this or that coin. So it's always good to look up everything and not to trust on these results. And you have seen that.
Also, you have. Sorry to cut you, Elisabeth. But I mean, differently from, for example, Byzantine seals, you have really hundreds of thousands of coins in Roman times, let's say broadly intended. So whereas, for example, for Byzantine seals, you have to, so we have, let's say, more or less 100,000, we say 100,000 seals, but of these 100,000 seals, how many have iconographies, how many are actually digitized, of how many we have pictures. So I think that in our case, we wouldn't even be able to create a useful data set.
Yeah. So that's in most cases the primary issue, to have enough data. And especially with regard to ancient images, in many cases we lack enough data. So it's really difficult to create a large data set for the training. So in this case, maybe a pre-training can help. No? So like we did it here, but then you have, of course, the problem that you don't really know the influence of this pre-trained data, and that it does not fit perfectly to your actual medium. Yeah, and that's quite a big problem. And coins are a nice example because, as you have said, we have so many of them, and we have very, very good photos of them available because also photo quality is a limit. Nonetheless, if you look just at the personifications, I would say the variation in comparison to the number of types and photos is not that big. So there is still, I think, quite an issue with regard to the number of photos if you go really into the details of the iconography.
Yeah, that's this is something, because I know that a project actually here in Paris, because I'm now in Paris in these days, has been dealing with neural networks for to detect images of crosses on Byzantine lead seals, because crosses are an interesting example for iconography in Byzantium, because they are actually just a cross, if you put it like that, but the variation are so many that and they are so important for datation that it's very important to see if, I don't know, the end of the right arm of the cross goes a bit on the to the right or to the left, this kind of small details. And they also have, I mean, the project is still going on, so I'm very curious about the outcome, but that's also in that case the data set is quite limited, so I'm very curious to see also in terms of results how big an impact the data, the original, let's say, data set can have.
So this is of course a big issue, and of course then the variation itself, no? So these ancient objects, they are sometimes a bit standardized, but not in an industrial way. So they are handmade. They should have variation in them, and this makes it, I think, very difficult to apply pattern recognition to them. And another question is, does it in all cases really make sense to use pattern recognition? Can we really access research questions? And we have seen in Sven's part that, especially with regard to the context, historical context, and so on, what is here really the contribution, the possible contribution of AI to our research? And maybe we can just jump into the discussion question. I have
maybe I can also say something while Elisabeth is searching the questions. It seems to me that pattern recognition is maybe a very nice tool, but for a very specific and probably also limited audience, namely numismatists who want to identify their coins, while for all those who are already a bit trained in how to identify personifications and the attributes in particular, might not need that very much. And then it's actually quite a thing of what we would call a capitalist cycle, which is, of course, not the way we look at these objects, as we are interested in what kind of political, economic, cultural, religious, whatever messages they embody. And I think this is also very important as we are doing historical research. We are not just dealing with patterns and how to identify them. That is what natural scientists do, and that's also very good what they do, but this is not the things historians do. They try to understand what's behind the object, around the object, and connected to the object. And this understanding is quite a different thing from just merely explaining what's visible, what can be recognized. And I think this has been already coined in the 19th century by Johann Gustav Droysen, who actually made our field become independent, on the one hand from religious studies and philosophy, and on the other hand, fighting against the rise of natural science and what they can do and where their limits are.
Of course, and I fully agree. And I mean, I for example, something that might be interesting pattern recognition to be applied to is particularly damaged coins, seals, whatever. So if the data set is big enough, and what you would like, to recognize, you can't do this with your bare eye, you can't do this with RTI, you can't do this with a well-made 3D model. So perhaps it might be worth it to give it a try and to feed, let's say, a good image of a very damaged specimen to see if something can be, let's say, can be recognized. But this, of course, needs a huge training, perhaps much bigger than what we can do in our time, and also with because I mean, also Roman coins, they're a lot, but they're not unlimited. So at some point that there also might come a moment in which the let's say the model says, I can't go any further. I can't recognize anything else. But we will have a comment by a student.
Yes, maybe also to first to answer to your comment, Martina. I also think it can be helpful in cases of reconstruction, given that it works well. So it can, for example, suggest different possibilities. Yeah, for example, we have these models that can now reconstruct Greek inscriptions or Latin inscriptions, and it gives you a number of ideas. And you can take this as a historian, as an input, and work with it further. So not as a reliable result, but maybe to get some ideas, yeah, you can use. But in this case, it is then, of course, first of all, limited to the identification, not to further questions, but first of all, just to say it's this type or that type, or maybe this period or that period. But of course, it can already be helpful for some studies. And then now I see also the comment by Danubius. Yes, exactly. So he says, I would think one would have to train models from scratch, and it would have to be in supervised, annotated training in order to be sufficient for scientific purposes. Absolutely right. So we to kind of exclude as much of this insecurities, we would have exactly to this, and maybe once, if ever the recognition rates for, say, standard representations are good enough, one might be able to use it to discover minor differences in representation. Yeah. So I think I absolutely agree with you. So first of all, we would need our own data set to train the algorithm in the very beginning. Nonetheless, I think the pre-trained are not that bad, but we would have to do supervised annotation. So that really the algorithm learns these attributions that are the basis for the identification. So as long as the algorithm has, so to say, no idea what is this or that pattern, it will never work sufficiently. So this we would really have to change in the with orange data mining, or just use then another AI. But I think this is a nice one to get access to pattern recognition. And yes, then learn the standard representations, and then go maybe a bit further. But Sven, you would
but I mean, if one talks about standard representations, there's already a big issue. What is the standard?
What is the standard?
Elisabeth has probably told very much, but we have, for instance, coins from a ruler in the Near Eastern region, and this ruler has also minted coins, Roman-like coins with personifications, but attributes are totally mixed. So it's not like the typical attributes of Venus or Juno or so are there, but sometimes it's seems like a Venus, but with an additional attribute that normally you see only with What do you do then? Then you are actually at the same stage like the ones having compiled the additions. Yes. And they sometimes attribute it to be a Venus, and other times they say it's a So then actually we just reproduce what others have already talked about and do not allow for ambiguity. And I think actually the topic of ambiguity is a very important one, because it shows us that there are not only standards, but that also sometimes these kind of things were played with and intentionally played with. And this is also a message we have to discover as historians.
Yeah, and especially also the variations are sometimes the interesting things. Yeah, really to see not only the continuity between this personification of goddesses, but also the differences. And usually in research, people say, in the Roman imperial period, they're also standardized. They all look the same. The personification, they're so boring because they're all the same. And this is also what interests is my research interest, actually, to show that there are a lot of differences in the iconography. Sometimes very small differences, but they have a meaning for the viewer. And this, I think, we can only address if we look at the variations and not at the standard. And this is, so to say, to think from the other sides.
I fully agree, also from a Byzantine point of view, because we, let's say, you said something very important, that, I mean, these representations were made for an audience, and this audience is not us. For us, they might be standardized, let's say, for our eye, as trained as it may be, because, I mean, we've been doing this work for, I don't know, a couple of decades now.
We are also pre-trained, yes.
And, but for example, now I'm not acquainted with Roman numismatics, but for example, in Byzantine iconography, you say, okay, that's St. George, but perhaps there might be a difference, and that's why I really like the comment about the differences in representation. There might be a very small difference in the representation that might reconduce us to a local cult. What do you know? And of course, this small difference was quite clear for the viewer back then, but for us, it's just not so, let's say, not so transparent. And of course, this is the big problem of the black box. That it does not, let's say, it does not very much allow for ambiguity. It does not allow for, it kind of imposes a standardization. And to the people listening, we had at some point earlier in the term a very nice class, a very nice session with our colleague from CCH, Hannah Bush, about HTR and, let's say, script recognition in manuscripts. And she talked about the black box, both the let's say the AI black box, but also the black box of the paleographer, because also us, we tend to be we tend not to be very transparent in the way we date a script. Why do we say, okay, this is the third quarter of the 13th century, without explaining, because at some point it's a feeling. I mean, for us it's a feeling, and for the AI is we don't know what it is, but it's not transparent. So I lost my thread in this moment, but you know what I wanted to say.
There is of course the same problem or similar problem with human researchers. Although we have to say then it's a mistake of the human researcher, because you have to make transparent. You have to say, okay, this and this and this are the reasons why I think it is this or this or that
exactly, which might be wrong. I mean, I hope that whatever I say is wrong and will be disproved in 100 years time, because I mean it will be so better by then.
Yes. Yeah.
Precisely.
Or polyvalencies in the images. It's also hard to grasp them. And you are, of course, right. Also in the annotations, this can already cause a problem. And it already starts maybe with the terminology.
Exactly.
Yeah? So annotation is really a big field to think about. I think you can do one session only about annotation, how to standardize these terms and so on. And of course, sometimes there is ambiguity, and there must be this ambiguity in the image, because this is exactly the message, that there is the ambiguity. But if you have to say it's either this category or that category, then it gets lost.
And this also is, which category or categorization you follow, because this determines eventually how you will model it, and then it's set for centuries, so to say. I mean, we nowadays try to question also what editors of standard reference works did, and we rightly do so. And then we see how we are actually framed by this, so that we do often not look left and right from it, but just follow these things blindly. And to some degree, it's also natural to follow that. But this is, of course, also something that should come out from this session, that not just to question AI and what's in that black box, but also to question all the steps that lead towards training or using the AI, because this is also part of our research, and this must be always critically examined.
And on this remark, I think we can close the session, because as I was telling to Elisabeth earlier, we in this term we like to talk, and we are already 11 minutes. So thank you so much. This was really brilliant, and I really hope that you will do another workshop in person this time. And
Hope so
too. Thank you again. Thank you to everybody who attended, and I will see you all next week.
Yes. Yeah, have a good time, and thank you for this wonderful session. Yeah. Have a great time.
Bye-bye, the three of you. Ciao, ciao.
Bye.
Bye.